Hello, it's Dorsan Mertz. Welcome to part 2 of ACT Math, where we're going to continue learning a little bit more about algebra. All right, we're going to talk about ratios and percents. Ratios are used to compare two numbers. They can be written three different ways. You can use a colon in between, like 7 to 8, or they can be written like look like a fraction, or it may be written in the words 7 to 8. The word percent simply means out of 100. For instance, 45% means 45 out of 100. And it's important to know how to convert them to decimals. And then you just move the decimal 2 places to the left. So 45% is the same thing as 0.45. We're going to talk a little bit about how to interpret words that you might see in word problems. That's how you usually see percents used. It'll be in a word problem. So when you see 75%, you'll know to convert that to 0.75. Of means multiply, and then 300, so 0.75 times 300 is where you put your equal sign, and when it says what, that's where you put your x. So 0.75 times 300 equals x, and the answer is 225. Similarly, if you saw 45 is what percent of 60, you put 45. Where the is you put your equals. Where the what is, you put your x, or whatever variable you're using. And then percent of 60, you're going to just multiply by 60. And when you get that answer, which is 0.75, you convert that to percent by moving the decimal point 2 places to the right. So 75%. 30 is 20% of what? So 30 is equals 20%. We convert to a decimal, 0.20. What is the x? So we just do 30. In order to get the x by itself, we'll divide both sides by the 0.20. And so 30 divided by 0.20 equals 150. Just see if that makes sense. 30 is 20% of 150. That makes sense, because if you times 30 times 5, it would be 150. All right, let's talk a little bit about proportions and cross multiplying. Proportions relate to ratios, and they're typically written as a fraction, such as 2/5 equals x over 25. 2 over 5 equals x over 25. And you solve for x by cross multiplying. So cross multiplying just means you multiply what's across from each other. So you would have 2 times 25 on one side equals 5x on the other side. So that'd be 50 equals 5x. Get the x by itself by dividing both sides by 5, and the answer is 10. You also use cross multiplication to solve fraction equations like this. X over 6 equals x plus 10 over 12. So you cross multiply, so you get 12x this way equals 6 times x plus 10 the other direction. So you solve, get x by itself, and the answer is 10. Let's talk a little bit about probability. The probability of an event occurring is you put your desired outcome over the possible number of outcomes. So if you were wanting to know what's the probability of drawing a red card out of a pack that has 50 red cards and 100 blue cards, then you'd put 50 over 100, and it would end up over 150. That's your total outcomes, and it end up being 1/3 after you reduce down. So the probability of two different events happening, if they're mutually exclusive, you just multiply probability of A times the probability of B, as long as it's mutually exclusive. That's like flipping coins. Mutually exclusive means that the outcome of one event doesn't affect the outcome of the other event. The counting principle also finds the number of outcomes. So if an event can happen A ways and another event that's independent of that A happening can happen B ways, then the probability of them both occurring is A times B. So let's look at some examples. This is a probability example. A bag contains 10 pieces of flavored candy, 4 lemon, 3 strawberry, 2 grape, and 1 cherry. One piece of candy will be randomly picked from the bag. What's the probability the candy picked is not grape flavored? Anytime you see a not or except, just go ahead and circle it so you remember that you're wanting to know what it is that's not grape flavored. So we have 2 grape flavored out of 10 pieces of candy. So that means There's 8 of them that are not grape flavored, so we put 8 over 10. Now that's not one of our answers because we need to reduce that down. So 8 over 10 reduces down to 4/5 E. All right, here is a counting principle problem. In the school cafeteria, students choose their lunch from 3 sandwiches, 3 soups, 4 salads, and 2 drinks. How many different lunches are possible for a student who chooses exactly 1 sandwich, 1 soup, 1 salad, and 1 drink? So we talked about it in the counting principle. One does not affect the other, so all we're going to do is multiply the possibilities times each other. So we got 3 times 3 is 9, times 4 is 36, times 2 is 72. So the answer is K. You'll also see these like they're usually at the beginning of the test because they're kind of easy, and it's like a guy has so many shirts, so many pairs of pants, so many pairs of socks, and so many shoes. So it's those kind of problems. You just simply multiply the choices by each other or the outcomes by each other. All right, absolute value is just the distance that a number is from 0 on the number line. So the absolute value of -5 is 5, and the absolute value of 5 is 5. They're both 5 units away from 0 on the number line. So if a variable in an equation is in the absolute value symbol, you have to find both answers. So if you have the absolute value of x minus 7 equals 2, you have to set it equal to a positive 2, and then you have to set it equal to a negative 2 and solve for both. So you get 2 answers, x equals 9 and x equals 5. You can go back and check. 9 minus 7 is 2, so the absolute value of that is 2. And 5 minus 7 is -2, and the absolute value of that is also 2. All right, here's a little bit of a absolute value problem that has to make you think for a little bit. For all non-zero values of A and B, the value of which of the following expressions is always negative? And this is one where you just have to go down and look at each answer choice. So A minus B, that is not always negative because A could be larger than B. Negative A minus B, that would not always be negative because B could be larger there, and so that's not negative. The absolute value of A plus the absolute value of B is going to be a positive number, so it's not that one. The absolute value of A minus the absolute value of B, that wouldn't always be negative because it would only be negative if B is larger than A. But if A is larger than B, then this would not be negative. So the only one that would always be negative is if you had the negative absolute value of A minus the absolute value of B. So there's no numbers you could put in there and end up with a positive answer in K. So K is your answer. All right, when you're solving inequalities, it's the same thing as solving equations. That's equations means you have an equal sign. So it's the same thing as that, except there's one exception. And that's when you multiply or divide by a negative number, you have to swap the inequality symbol. So if it was a less than, it becomes a greater than. See here, we're dividing by the -3. So we got to swap that less than and turn it into a greater than. Let's work a problem. So which of the following inequalities is equivalent to -2 minus 6y is greater than 2y minus 4? So we see in our answer choices, we want the x on the left-hand side. So we're going to subtract the 6y from both, or add the 6y to both sides to get rid of it. So when we add 6y over here, we're going to get 8y minus 4. And we got -2x on the left. Now we know when we divide by that -2, it's going to swap it from greater than to less than. So we already know that any of them that say greater than are eliminated, like B is eliminated and E is eliminated. And when we divide that 8 we had by the -2, we know that that will be a -4y. So even if you didn't go any farther, you know it's going to be x is less than -4y. There's only one answer that has that, and that's A. But if you did work it on out, -4 divided by -2 would be +2. All right, which of the following is a solution statement for the inequality shown below? When you have one like this, you're going to have to solve 2 inequalities. You're going to have to solve the left side first and the right side next, and then you're going to have to choose your answer. So if we solve the left side, we want to get x alone. So we're going to add 1 to each side, or add a -1 to each side. So we got a -1 plus a -5, and that gives you -6 is less than negative 3x. And so we're going to have to divide by negative 3. And we know when we divide in an inequality, we got to swap that sign around. So it's going to turn from pointing to the left, it's going to point to the right. So we're going to end up with 2 is greater than x. Now, if we solve the other side, we come up with x is greater than negative 3. Now, of course, you always put the lowest number on the left and the higher number on the right. So here, x is less than 2. So there's x is less than 2, and x is greater than negative 3. So x is greater than negative 3. So it's going to be between negative 3 and 2. Okay, here's some vocab for word problems. We already learned of means multiply, is means equal, what means where you put your variable, your x. So increase means add, less than means subtract, times or product means multiply, times the sum means you multiply a number by quantity. So an example of that would be 5 times the sum of a number and 3. You would turn that into 5 times a number plus 3. So inequality signs are used for at least. When it says at least, you're going to be using the greater than or equal to, and at most, you'll use a less than or equal to. Less than, you're going to use, the less than symbol, and greater than. So the product of x and 6 is greater than 2 would be written x times 6 is greater than 2. The sum of a number x and 4 is at least 9. So x plus 4, when we say at least, it's got to be greater than or equal to, because it could be just 9. So x plus 4 is greater than or equal to 9. Pay attention to those symbols, the inequality symbols, which way they're turned and whether they have the equal sign under them or not, because that will help you eliminate some answer choices. Sometimes you have to create and assign variables in a word problem. So you take what you know and you express what you don't know in terms of what you do know. So here's an example. Max is 3 years older than Ricky. So we would make Ricky's age X, and we would make Max's age X plus 3. And then we would use that. They usually give you more information, and then you would use those terms, though, to solve the problem. So that's all for part 2 of ACT Math. In part 3, we're going to talk about some basic geometry, some plane geometry, because besides basic algebra, that's the next most tested thing on the ACT. So I'll see you next time. Bye-bye.